Have you ever actually stopped to think about how nature, fundamentally powers itself? We look at a forest or an ocean, and we just see plants and animals doing their thing. But what we're really looking at is this incredibly engineered, highly structured biological infrastructure grid. Today, we're diving into this explainer to track the exact flow of energy and matter, really seeing how nature keeps the lights on. Okay, here's the blueprint for this infrastructure grid. We'll start with nature's trophic infrastructure grid, then move to producers, the pyramid base, followed by heterotrophs needing organic matter. After that, we hit the 90% energy drop, then decomposers, the recycling crew, and we wrap up with linear energy versus cyclical matter.
So, Section 1. Nature's trophic infrastructure grid. Systems functioning smoothly.
You see, an ecosystem isn't just some random assortment of life. It's a highly organized machine. Systems function smoothly here simply because organisms are strictly categorized. They fill very specific operational profiles that direct two main forces, the continuous flow of energy and the cyclical movement of matter. Energy pushes through linearly, straight ahead, while matter spins in an endless loop. But to really grasp how that whole dynamic works, we've got to figure out where the power actually enters the grid.
Which brings us to Section 2, producers, the pyramid base, the foundation units.
The absolute key takeaway here is that nothing, and I mean literally nothing else in the system works without these foundation units. Technically, we call them autotrophs. Honestly, just think of them as nature's solar panels. They are the only part of the grid capable of pulling in raw power from the outside. They capture solar radiation directly from the sun, and through photosynthesis, they convert it and lock it away as stored chemical bonds. Basically, every other living thing out there is just running off the batteries that these producers charge up.
Moving on to Section 3. Heterotrophs needing organic matter, the secondary processors.
So, because they can't just make their own food out of sunlight like the autotrophs do, consumers, or heterotrophs formally, function as secondary processors. By definition, they have to ingest alternative organic matter to secure the energy they need to survive. They're entirely reliant on all that heavy lifting the producers already did. Long story short, they gotta eat to live. Now, imagine this entire structure as a massive pyramid. At the very bottom, we've got our widest base, the producers. As energy passes upward, we get step 2, the primary consumers. Up again to step 3, the secondary consumers. And finally, we cap it off at the top with step 4, the tertiary consumers. You'll notice how the pyramid's width visibly narrows with every single step up. That narrowing shape, it represents a hard, unbending law of how energy actually behaves in this grid, dropping off as heat at every step of the journey. But before we dig into exactly why that pyramid narrows so much, let's just briefly categorize who's actually hanging out on those steps. These heterotrophs are classified entirely by what they eat. Herbivores are our primary consumers. They're eating the producers. Carnivores are the secondary and tertiary consumers executing predation on other animals. And omnivores, well, they sit somewhere right in the middle, eating a mix of the whole shebang. All right, Section 4, the 90% energy drop, losing heat. Okay, the absolutely crucial thing we need to wrap our heads around here is this staggering mathematical shift, 90%, as energy moves linearly down the chain from the sun to the producer to the consumer. It drops off sharply by roughly 90% at each higher step. Actually, scratch that. It doesn't just drop off. It is a massive, unbelievable loss of power. When a primary consumer eats a producer, or a secondary consumer eats a primary one, they don't get 100% of that energy. No way. A massive 90% chunk is completely lost to the system as metabolic heat. Just living, breathing, moving around, it burns that energy away as heat that radiates out and completely vanishes from the grid. Only 10 measly % of that stored energy is actually passed on to the next level. To put that into perspective, this is exactly why you'll find thousands of blades of grass for every single rabbit and hundreds of rabbits for every hawk. The system just loses way too much heat to support a wide top. Next up is Section 5, decomposers, the recycling crew, saprotrophs. So with energy constantly leaking out as heat everywhere, the actual physical materials left behind have to be managed. This operational category includes organisms like bacteria and fungi, and honestly, their job is absolutely essential. They deconstruct dead tissue and complex organic waste, breaking it all the way down into inorganic base elements. By doing this, they're returning vital nutrients right back into the soil and the air inventory. They are literally restocking the shelves, making sure the producers have the raw materials they need to start the entire process over again.
Which brings us to Section 6, linear energy versus cyclical matter, two distinct dynamics.
These two dynamics really bring everything together. On one side, we've got energy flow. This is a strictly linear path. It comes in from the sun, goes to the consumer, drops sharply by that crazy 90% at each step, and is permanently lost as metabolic heat. It's a total one-way street. But on the other side, we have matter cycling. This operates in completely closed loops. The physical stuff, the actual matter, circles indefinitely back and forth between living, biotic structures and non-living, abiotic reservoirs. What you should really take away from this explainer is just how deeply connected you are to this grid. No joke, every single atom of carbon, nitrogen, and oxygen currently making up your body has been circling indefinitely through this exact system. Those atoms, they've been built up by producers, eaten by consumers, broken down by decomposers, and returned to the air and soil over and over again in this infinite, beautifully closed loop. And that brings us to a really fascinating final thought to ponder. We know that matter can be recycled forever by our decomposers, right? But since energy flows linearly and constantly depletes out of the pyramid as metabolic heat, what do you think would be the ultimate limits of an ecosystem without the constant, immense, daily influx of power from our sun? It really puts into perspective just how fragile yet unbelievably engineered our planet's biological grid truly is. Thanks for exploring this with me.